Okay, it's time 11 a.m. Good morning, everyone, or good afternoon. This is Cherry Kubota. I'm a professor at the Ohio State University and also the director of Ohio Controlled Environment Agriculture Center. So this is monthly Indoor Ag Science Café supported by three groups. The original founding group is the OptimIA group, led by Michigan State University. And then the second group is Advanced CEA, led by Ohio State and then also Rutgers. And then CEA HERB, also led by Michigan State University. So basically, we are gathering together once a month and then share science-based information to move the industry forward. So we have great talks and presentations upcoming. But what we usually encourage are two types of presentations. One is academic speakers based, and the other one is industry speakers. And we welcome nominations, suggestions, self-nominations. So that is a great thing. We can do that relatively informal way. So all the previous cafe presentation parts, not the presentations only, but not the discussion part, recorded and share in OptimIA website. This website might change in the future because we are ending the OptimIA program. It would be migrated into a new website. That's my understanding. Okay, so upcoming presentations today, I'm gonna introduce in a minute, but Dr. Xinhua Jia from North Dakota State University is going to give a presentation. It's kind of engineering approach, right? So we like to talk about engineering technologies in addition to biology and science and production techniques and things like that. So I really appreciate Xinhua, you are doing this. So the October we have Grodan, the substrate company Grodan, Rockwell, talking about North American-based recycling program of the Rockwell materials. This is great information, so don't miss that. November 4th, we have another private sector. She's a very well-known person for the photobiology area, and now she's a consultant, Dr. Tessa Pocock, talking about photobiology of plants. And then December, we have three academic researchers sort of, team presentations, three different topics under the big project title, tailoring hydroponic factors to control the environment production of emerging food crops. So this is something you might want to listen because emerging crops, new crops is always nice to learn. January, we have another private sector. She's very, very instrumental, worked in many different companies, Dr. Melanie Yelton, who is going to talk about new grower association she's putting together with her colleague, and then the title is Building the Future Together, the United Greenhouse Growers Association. So we are so excited with all, good presentations upcoming. So stay tuned, stay connected, and we are sending out with multiple channels. So please not be annoyed with multiple similar emails coming from us because we are using all the available lists. So, okay, today's agenda title, presentation title, Smart Irrigation for High Tonal, Smart Irrigation for High Tonal Specialty Crop Production. Dr. Xinhua Jia, North Dakota State University, is gonna talk about this. This is quite unique, right? So the high tonal is really low tech, but introducing more smart approach. I think that's what I am excited. So I'm looking forward to learning more about her research. So I'm stopping presentation here and then have Dr. Jia take over the presentation.
Well, thank you. And thank you everyone for being here. And this is a different topic than the typical CEAs, but it's practically happening somewhere in the US or a lot of places. So I'm going to cover the smart irrigation for high turnover specialty crop productions. And my name is Xinhua Jia. I'm a professor. And this research is really based on my graduate student, Sravi, and she's about to graduate probably in 2 weeks. We came from Department of Agricultural Biosystem Engineering, North Dakota State University. So in this talk, I will give a general overview of high turnover and specialty crops, and irrigation needs for crops in the high turnover and smart irrigation, as well as a case study at North Dakota State University. So what is high turnover? High turnover, I don't know the audience, so I kind of change the word here. So high turnover could be this hoop houses or polar tunnels, or you normally call it unheated or greenhouse. So this is mainly like a plastic covered frames tall enough for people to walk in. It can extend the growing season without other heat source. Crops usually grow in the ground, and plastic normally is a double layered with air that blow in between so that it will have a better insulation, strong structure against the wind and the snow and the longer life. In general, the temperatures that inside the high tunnel is about 8 degrees warmer than that outside. So there are many different type of high tunnels. As you can see that on the top, the the middle top is a Gothic high tunnel, and then right below that is a Quonset or caterpillar. The reason that for them that's different because the roof shape that's different, and you can also have a single bed high tunnel or a multi-bed high tunnel. Also can be a permanent high tunnel or mobile high tunnel. So it depends on, the way you set up. So, with the high tunnel, what can you do? Because you do have an actual 1 month in the spring and another month probably in the fall. And so there are a lot of crops you can grow, but the top fives are tomatoes, peppers, cucumbers, leafy greens, and strawberries. I know we have a producer grow cut flowers, but they're not ranked, on the top. So with these crops, with one additional month in the spring, another month in the fall, normally you will have a higher yield, the higher, better quality. And of course, with a higher yield, better quality, early in the season and later in the season, you will have a better market price. So that's why, this high turnover is expanding in the country. But with the high turnover, they also bring a lot of challenges. So the number one is that irrigation is a must. Why? Because you do put the high turnover, it prevents the rain directly fall on the ground. So you must apply the irrigation, to the crops. And when you do apply irrigation, it could be under irrigate, over irrigate. Another thing is any water you use for irrigation, it does have some salts, especially if you use groundwater. So that's why the salt can really build up. Another thing is a soil health problem. And because inside the high tunnel is a very narrow or crowded space, you will have a frequent traffic and footprint. So that will bring compactions and also the soil salinity issues in the ground. And of course, with like a high intensified cropping season, the soil-borne disease could be another issue. Yes, you can use rotations. You can add compost or cover crops. You can leach the soils. You can do deep tillage. You can use gypsums to amend the soil. But you know, the problem will still be there. And nowadays, a lot of people try to adopt this soilless system, which is the battle buckets. So that's why I said this system is still related to CEA, because a lot of the growers right now tend to use a different type of hydroponic systems inside the high tunnel. And then, you have the temperature humidity problem. In the spring, yes, warmer temperature that protect the crop, but then in the summer, you can have a heat stress. So that's why a lot of people had to put on like a sheet clothes on top of the plastics. But then the sheet clothes, you turn on and off. It's very tedious. And for the turner we use, we roll up the size. We have a temperature sensor, and then we automatically roll up the size to have the temperature that's mediated. And we also have a fans and a venting system to make sure the temperature and the humidity inside the tunnel is favorable for crop production. Another thing that's really challenged high tunnel is the initial cost is very high. But thanks to the NICS equip funds, they can cost share a lot of the high tunnel initial costs. That's really promote the high spread of the high tunnel installations in the US. So as we just mentioned, that irrigation is a must. And then what about the different type of irrigation that can be applied inside a high tunnel? Well, the most popular strip irrigation. So the water is directly delivered to the root zone. And sometimes you may have this sprinkler or overhead irrigation. And some producers would rather prefer, just grab a hose and water your plants say as needed. And also on the top left corner, this is a soaker hoses, basically as a porous a tube that's put in the root zone and slowly release the water, and you just turn on and off. And then you can also, we have these hydroponic systems that directly apply, the drip to the hydroponic or the batter box. So these are, the different systems that can be used in the high tunnel. So for the drip irrigation, as we use in our system, it is a method to deliver slow, frequent application of water to the soil using a lower pressure distribution system. Most of system we use is between 10 to 15 psi. So that means if you use groundwater, which is the higher pressure, you do need a pressure regulator. Make sure that your pressure is within the right range, so that your system will work. On the picture, as you can see, that we set up the irrigation system, and under the black plastic tube, a plastic mulch, we do have two drip tubings. And then as you can see, this is one of the undergraduate intern, and he's putting the joint, the connections. Remember, this is a research project. We have a different irrigation treatment, so that's why we had to make a lot of connections compared to a typical farmer's field. And regardless, the different type of drip system you use, normally we do have a systematic approach. So a drip system, yes, you will have an emitter, next to the crop. They will control the water flow and the placement. And then above that, you will have laterals that deliver the water to the emitters. And then you will have a maze and sub-maze deliver water to the laterals. And on top of that, you will have a control station. So the control station, you will have the water source, the pump, the valves, filters, pressure regulators, and pressure gauges. For our research purpose, we do have a flow meters as well. And so that's the systematic approach. And so depends on what you have. You may have all or some of this part. You may not have everything. So when we have the drip irrigation, the best part about drip irrigation is high efficiency. So if we even consider the efficiency as 100% because we put like 2 drip tips that's very narrowly near the crop root zone. And so we don't really, have any deep percolation or seepage. And because we have the mulch, and evaporation is also very minimum. So that's good, the high efficiency. Where the challenge part is the management of the drip irrigation, because we only deliver a very small amount of water to the crop, and it is a small amount, so there's a very little room for mistakes. You cannot get behind. You cannot really, if your electricity failed or whatever, your system, your crop will really suffer. And also drip irrigation have a higher requirement for water quality. So water quality can cause the drip system to be clogged and also cause the salts to be built up in the root zone. And also with, depends on what kind of salts you have, the salts can also eliminate or limit the water movement or nutrient movement to the, root zone. So that's another topic. So now you have the drip irrigation, and how do you manage it, or how do you schedule it? Normally, irrigation scheduling is determine the amount of water that you will need, and also how long that you will need to irrigate, and when to irrigate. So with this smart irrigation system of the drip irrigation, so you can people do, turn on and off the irrigation manually, or they use a timer, turn on and off the irrigation on a fixed schedule for a fixed duration. And you can also use this water balance or energy balance, the checkbook methods, so many methods developed for the irrigation scheduling. But for our study, we want to turn on and off the irrigation based on, a crop or soil or weather conditions automatically and remotely, if that's possible. So that's what I'm going to do. And if you're a farmer, you say, oh, you talk a lot. How am I, exactly going to do? So I like to ask questions. So the first question is, do you have water? So if you don't have water, nothing will move on. And if even you have a water, that's great. If you don't, can you harvest the rainwater around your high tunnels? Can you bring some water from somewhere else to your high tunnels? If that's possible, that's great. And then the next question is, what is the quality of your water? You need to check the salts and the chemicals and the contaminants. Remember, some water, they're not suitable for irrigation. And the next question is, do I have a power supply near the controller? And if you don't, that's fine, because some controllers do work with battery, or you can set up a solar panel that working for your system. And if you do have a power supply, and next question is, do you have a Wi-Fi? Because if you have Wi-Fi, we can do remote control. And if you don't have a Wi-Fi, yes, you can set up a mobile Wi-Fi system. So, and then when you have the Wi-Fi, the next thing is, what will be the frequency for my Wi-Fi? And you'll be surprised that when we start this research, how many mistakes we make, because each Wi-Fi, they have a different frequency. But for your Wi-Fi, you only have one frequency. So when you buy the controller, make sure you buy the controllers that's compatible with your internet system. So then you go to internet, you buy, and then you see some of them like $400, and some of them is only like $65. And so what exactly you're going to buy? And because all these controllers, they work differently. Some are really, time-based, just like a timer, and some are ET based, basically it's weather based. Others are plant stress based. And then the one I work is a soil moisture sensor based. And now, if you look at the innovative research, or the trend is the IoT based smart controllers. So the two controller types that I used, one is a Eurometer watermark and controller. So these are a battery-based controller system. Another is a Hunter HydroWise software applied controller with the Eurometer watermark sensors. And these are, web-based or Wi-Fi-based. So my former graduate student gave a nice summary about smart irrigation, put these icons here, then I use it here. So smart irrigation is automatic, it's a sensor incorporated, remotely controlled, and provide precise irrigation with high efficiency, flexible scheduling, as well as this system will save the labels and costs. So for NDSU high tunnel experiment, as you can see that we have a imaged experiment, a half inside the high tunnel, the other half is outside the high tunnel with 8 varieties for tomatoes and 8 varieties for pepper. And then we have a 3 irrigation treatment. One is a time-based, just based on what people used to irrigate. So the time base is irrigate Monday, Wednesday, and Fridays. And then we have a 10% MAD and 30% MAD. We covered with black plastic, which is based on our previous study that black plastic works best for tomatoes. Normally inside the greenhouse, we will start like 1 month earlier than outside the greenhouse. So inside the greenhouse, in the green pepper area, we also have a weather station. We measure part air temperature, relative humidity, and soil moisture and temperatures, and ET gauges for a reference ET, and also additional soil moisture potential sensors to kind of get the in-field soil moisture potential relationships. So, for our field, we have the mulch and then green pepper here, and we have a watermark sensor. It's connected with this soil click. This soil click has 9 levels, and each level represents a different moisture level. And then this soil click is connected with the controller. This controller is kind of a modernized timer, and whether it's on and off really depends on the signals that the soil click sent to it. However, we set up the time or the duration, on the controller. And then the controller is connected with the solenoid valve. And the solenoid valve is connect to the irrigation, in the field. And then the entire system is controlled with our mobile phone. And we also schedule the irrigation like 3 times per day. And, it will be like if needed, it will irrigate. Otherwise, it will just bypass. So these are some of the soil properties for this site. We had to have the soil characteristics and soil physical properties that's estimated for the soil. So this part is what we did behind the thing. And so I did a estimation what would be the moisture content at 10% MID and 30% MID. So then you ask, what is MID? So MID is management allowable depletions. Basically, it's the maximum amount of plant available water allowed to be removed from the soil before irrigation refill occurs. So on the left side, it's a sandy soil. On the right-hand side is a clayey soil. And we use field capacity, which is the top of the moisture, and permanent waiting point, which is the bottom of the soil moisture that the crop can use or the soil can hold. So at field capacity, the MID is 0, where at a permanent waiting point, the MID is 100, means the 100% you need to refill that soil profile. So you can have 30% and 60% of the MIDs. And then here, you can describe this MID based on the actual water content, or you can describe these MIDs based on the soil potential. So here is soil potential with the soil moisture, which is the soil characteristic curve. As you can see that if you describe your soil with the soil moisture, it's like 31% and 29%, it's like a very narrow range. We know like most of the soil moisture sensors is plus minus 2% accuracy. So if you do use soil moisture sensors, the range that you can work is very narrow. So that's why the controllers, they use the soil potential sensors, which is, have a much larger range that you use like a 14 kilopascals or 27 kilopascals, equivalent to that moisture content. So for this side, as you can see that when we have the 10% and 30%, and we for 10% MID, actually, it's 29.4 moisture content, equivalent to 14.1 kilopascal. But then we round up to 10. So that means whatever reach 10, we will irrigate, but we irrigate a small amount. And Sravi put a nice flow chart here to show that, how this system really worked. So I'm going to show some results from Sravi's dissertation. And as you can see that we did observe the air temperature inside and outside the high tunnel. This is the daily average air temperatures, may not really show the difference, in a critical stage. But again, inside the high tunnel in the later of the growing season, 2022, as you can see, it's much warmer. We didn't use shade clothes. But the temperature are different. And this is the humidity. As you can see that the humidity levels seems like about the same because we do have the sidewall. We also have the venting system. So that really maintains the moisture that inside the high tunnel about the same as outside. So we don't really have a mold problem, in a crop. And this is the daily average PAR readings. As you can see, this PAR readings is really the radiation that contribute to a crop growth. And outside, the PAR ratings is much higher compared to inside. Actually, in average for the year, only 45% of the PAR the inside, the PAR value inside is only 45% of outside. And this is because this plastic cover is really aged. The high tunnel installed in 2016. I believe the plastic changed once, but normally they recommended 3 or 5 years you need to change that. And so as you can see that the radiation is low. And then this is a rainfall, as you can see, 2022 and 2023. 2023 it rained a lot, But 2022, the season is more dry and irrigation is probably much needed. And outside. And then this is the reference ET inside and outside. I know in one of the high turnover workshop, when people asked, what about the reference ET or the ET inside the high turnover? As you can see that the inside is about like a 80 or 75% of outside. And also because we use mulch normally reduce the evaporation, so the crop will probably use less water inside with the mulch, with the high turnover. So this is the plant management. As you can see that normally is 1 month earlier inside than outside. And then they should be harvested late, but 2023, as you can see, is almost like 20 days late. That's harvested. However, in 2022, there's a frost damage. We should put a cover, and we didn't. We thought we can be safe, but crop just died, and because of frost, very cold temperature. So, this is irrigation research. As you can see here, that the blue bar is the time-based, orange bar is MID 10%, gray bar is 30%. So the amount of water, for 2022, the 30% MID use more water than the other two. But then in 2023, the time-based use more water. Probably the soil just more favorable, for the plant growth, and then the plant doesn't really need water. And this is the yield. As you can see that the MAD 30% does provide a better yield for in 2022 inside the high turnover. And for tomatoes, but then for 2023, and it is also inside provide a much better yield. And so this is the irrigation. We just try to see determine the irrigation efficiency. As you can see that compare these two, there's a significant difference between inside and outside. And irrigation effect in 2023, also a significant difference between inside and outside. And this is the water use efficiency. As you can see that the MID 10 actually have the highest efficiency. Well, if you I just talked that the MID 30 actually use more water. So this is kind of a balance between the yield and the water usage, because the water use efficiency is estimated from the total yield and the total water applied, and assuming here as 100% water that used by the crop, because we have such a small area. So if we can draw a quick conclusion here that the high turnovers are beneficial for vegetable productions in cold climate like North Dakota. Irrigation scheduling uses controllers or smart irrigation, and these soil water potential sensors can make irrigation automatic and more effective. And tomatoes have the highest yield with 10% MIDs, and peppers is highest yield with MID 10%, but the efficiency is different. So we want to thank Dr. Donlin and Mr. Colin Altward who did a lot of the work. Another graduate student from Plant Science worked with Thrive on this. And this research was funded by North Dakota Department of Ag Specialty Crops. Thrive also got funding from NDWRR for her work. So with that, I'm going to stop here for some questions. Again, I had hoped that Slavi can present her research results, but she is moving and not available. So that's why I hope I have captured the majority part of the work. Thank you.
Okay. Well, thank you so much, Xinhua. It's really nice to learn what you do in the high tonal optimizing irrigation.